When you run simulation, you take calculate. Normally, your calculation should not be more than 1 second. Go back to the machine. No, take run simulation.
Run simulation.
Yes. Take calculate. Your calculation should not be more than 1 second. If it's more than 1 second, then there's a problem.
And last time was a good second.
In fact, you should not be able up to the second.
You don't let my man feel. That data this boy.
I mean, why would you take that? Okay, if you look at that guy, they give you the oil production rate, the oil recovery rate, the oil recovery factor, right? How it varies across time. Have you seen that? You see that as time goes on, the recovery factor is increasing. Yes or yes? So that's just to show you how the quantity of oil that has been produced over time. You see, then you take done. You can go scroll down to be sure that it keeps increasing. You take done. You go back to the machine. Now remember that we model that guy without aquifer, right? Mm-hmm. For you to prove that truly there is no other extra energy, you have to do water current matching, FW matching. When you do that, if it's just a blue line, then it shows that truly there's no other extra energy. But if you have a blue and a green line, it means there's an extra energy source that you do not model. But some people have just green line, water influx. You see, in that reservoir you have water influx because you have a green line showing an extra energy source. Then you have a blue line showing how the rate of water produced from the reservoir increases with time.
It means I don't produce any water.
So, okay. As assignment.
Nice one.
You guys are going to model this reservoir with water influx. You model this same reservoir with water influx and evaluate the impact of water influx on the performance of the reservoir or on the estimation of the reserve in place.
What?
Evaluate the impact of water influx on the estimation of the reserve in place. Yes, that's it.
How are we going to do that actually?
He said we have how many flows. The main aim of considered paragraph. The main aim of the estimation is to reserve estimation, production, prediction, right? Yes. Now we have used MBAL for reserve estimation. We are still going to use that MBAL for prediction. You see? Yes. So we are done with the first part with reserve estimation. Now the next thing is from what we have estimated and from the simulation, where you ran simulation, right?
Yes.
You saw the recovery factor. Now it gives you an idea of the cumulative oil produced. Now from that period of time, how long will it take for the reservoir to be depleted? Right?
Yes,
That's now running prediction. So for you to run the prediction, you go under production prediction. It's an icon in the MBAL, right? After it's matched, you go under production prediction. The first thing you will see is prediction setup. So you click on it. Now the prediction setup now gives you an idea of a number of a day in which or months right? Like, should we predict every after a month, after 15 days, after? Are we there?
Automatic.
Yes.
On automatic.
Now, is it now when you predict, then you know if the performance is reducing with time or is increasing. So you have to predict like that before you come and do optimization. You said you predict, you estimate reserve, you predict and you optimize, right?
Yes, sir.
So yes, you come to this, you take user define.
Under
Take user
prediction
define.
step size.
Under prediction step size, user define. So if you want to allow 15 days, you allow 15 days. Right?
Yes, sir.
You allow 15 days. Now, prediction end. You allow it to be automatic. Because you don't know when the reservoir will be depleted. Right? So you allow prediction end to be automatic. Let them predict based on saturation and based on recovery. You see,
Yes, sir.
but when you decide when the prediction should end, like if you put maybe 2030, right? 2030, maybe it might not reach that year.
Then
You get?
but you
Then
before.
after if it reaches years before, then you see that the values will be the same all throughout till 2030, showing that they have already depleted the reservoir. But if you take automatic, it goes to the year where
you're supposed to end.
it's supposed to end. But you can still decide the date, maybe 2026, 2027, right? Yeah.
Like the day that you were expecting.
That you're expecting it to stop. From exploration, that's now if you have exploration data, right? Those who always do survey will give you an estimate that if at the end of the day you want to produce at this rate, it will last for maybe 10-15 years. Right? Are we there? Go back to production research. You see production function. Right? Production and functions. You take yes. What you are interested in is actually the oil production rates, right? Average oil production rates, and you want to see how gas will vary also within the reservoir. Then you are the oil production rates. So after that you take down. You validate and take down. You are not even putting anything there. It's just for you to, are you concerned with average oil rate? Reporting schedule. You decide. User define. You take user define. You decide if you want to have it after 1 month, after 2 months, or you want to have it in years or in days. You can change it. If you want to have a month, you allow the months. If you want to have in days, you change. Right?
Yes, sir.
You change. If you want to have in weeks, you change. In month, you change. In year, you change.
Which one is best fit, sir?
You can take a month.
Alright.
Because the data was reported every 1 month, right? From the data set that you have, it's every 1 month.
Yes, sir.
So you can maintain that trend. But it will still change.
And we take done.
So when you take,
I've never choose the number of
when you take, if you are there, you take done. Please ensure that the star is not in front of the one. If you notice, after reporting schedule, your run prediction is not showing, is not visible, right? Yes, that's because your production constraint was not imported from the input section. Automatically, your production constraint is supposed to be imported by the software into the input system after you validate. But that's not the case we are seeing there. So you go back to input. No, don't take input. Another copy. You go back to input. You take tank data. Go back to input, take tank data. Then you take production history. Take production history. Are we there? Take production history. You copy, you click on where you have time. Click on where you have time.
Where's that?
Just that time down with that.
Alright.
Are we there? When you right click on it, you will see an option to copy the table. Right click on where you have time. Time, yes. Right click.
But if you are grouping,
Yes.
Yes.
Take down, you go back to production prediction, go under that constraint and paste it there. Right click again on where you have, right click on where you have time. The same way you copy. When you right click, you paste.
I don't be input the two data then. They will
Where you right
attend
click?
that class close for 4:30, so
You
he
paste.
make attendance.
Then you validate.
My first attendance that because class be empty. And so then
Are you there? You're going to take validate, take down. You go back on that production prediction. Run prediction will be showing now.
Yes, sir.
Is it showing? Yes. You calculate. You have calculated. You calculate. I'm sure it's going to take you to about. They will tell you your tank pressure dropped to 0 after 1991. Some will show you, but rather based on saturation. Gas in place. Where? After 1974. You see, once you start having this deviation, it's showing that from 1989, though prediction normally will end at 1990, but from 1989, you will now have a problem. See now? From 1989, you have a problem. Maybe that your oil saturation is less than residual oil. Do you wish to continue? When they give you that option that your oil saturation is less than residual oil, it means they have produced, that means the reservoir fluids, right? The hydrocarbon has already been produced completely after 1987. The reservoir will no more produce. You can end there. You can take note. But if you wish to continue, that you produce and produce water, right? Yeah, you take yes. You take okay. Yes. And now you not show now. Yeah, even Junior and Maguire, or it's Oris. As per Junior and Oris. No, I was struggling to remember your thing. As per Junior and Oris, you will see that they are. It shows that their work can produce right down to 290.
2019.
Did you take this thing, gas injection, when you were doing constraint?
I'm shocked that
Wait. You model what the reservoir can produce under natural energy to a particular point. You see, it might even show that the reservoir, the fluid within the reservoir is depleted, whereas it's not depleted. It's maybe because of the energy that is depleted. So now you have to go and remodel, checking what if they should apply the secondary oil recovery there or enhanced oil recovery, and that will be under prediction setup. So the reason why I'm doing this prediction is to see how far the reservoir can go with natural energy, right? Now you go back, when you do this, you see the number of years it can produce with natural energy. You go back now to you take done. You go back now to prediction setup. Then you take modeling now with some constraints like with gas injection, with water injection, to see which method will be used to enhance the performance of the reservoir.